In this video, we'll take a look at an application of polynomials and how we can use polynomials and some of the things we've seen in this unit to solve problems. So here's our example. A box has dimensions such that the length is 3 times the width, and the height is 2 more than the width. The total volume of the box is 288 cubic centimeters. So find the dimensions of the box. Okay, so we've got a box and it's in 3 dimensions. And the length is 3 times the width. So if this is the width, this is 3 times the width, and the height is 2 more than the width. So the height is the width plus 2. So take a second and design either a picture or some statements or a chart that helps define all your variables. It's definitely a crucial step, and it's one part that a number of students over the years that I've taught have difficulty doing. So just slow down, draw a picture if it's applicable to draw a picture or a chart, or in some classes you may have written let statements. So define your variables clearly to yourself so that moving on in the question is a lot easier. The next step after this is to see if we can come up with an equation. And it's not just an equation, it's the equation that we want to solve. So in this case, that equation is going to involve volume. And the volume of this shape, which is a box, which is a prism, rectangular prism, is the area of the base times the height. Many people just memorize this as length times width times height. I'm a big fan of understanding area base times height because it works for a lot more objects. So in this case, the area of this base, well, that's this rectangle. It's length times width, so it's w times 3w, and then that's multiplied by the height, which is w plus 2. And we've been told that this has a total volume of 288. So on this side, I can substitute 288. So I've found my equation. Step 3 is to go and solve this equation. And this is where elements of this unit are going to come in, as well as some things that we've learned in the past. So 288 is equal to, this is 3w squared times another w is 3w cubed, and then 3w squared times 2 is 6w squared. And I set this equal to 0. 3w cubed plus 6w squared minus 288, and I start to try and factor this. And the first thing that I can try and factor is any kind of common factor, and in this case everything can divide by 3. So this is w cubed, this is 2w squared, and minus 288 divides by 3. I knew that because 2 plus 8 is 10, plus another 8 is 18, and 18 divides by 3, which means 288 divides by 3, and I take away 96. Now I try and factor this. Well, I can't factor this trinomial in ways that I learned in past grades. I'm going to actually need to use some skills that I've learned this year. And so I start by thinking about possible factors of this. And all of the possible factors are the q and the p value divided, and all of those factors. So let me just quickly list them out. It would be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus, does 4 go in? I think 4 goes in, let's check. It would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, plus or minus 32, plus or minus 48, and plus or minus 96. Now that's a lot of factors to go check. And what I'm saying is x plus 1 and x minus 1 and on might be factors. But the answers to those are going to be not x's, they're actually going to be w's, and my w is my width. And so I have to notice at this point, or at least at some point, what values I can and can't have. And so as I'm solving this, I have to keep in the back of my mind what restrictions there are on W. And one of them is that W is going to have to be bigger than 0, because you can't have a negative width. So in that case, I actually cut down my possible factors by half. I'm not going to look at any of the negative factors. So that helps a little bit. Now I need to use the factor remainder theorem to see which ones might actually work. So I can start with the easiest ones, which is plus 1, since I don't want to use any of the negatives. Actually, let me rewrite these factors so that we don't put all the negatives in there. And that list certainly looks a little bit better. And now we start testing. So if I put 1 in, I get 1 plus 2, take away 96. No, not big enough. 2 in here gives me 8 plus 4 times 2, 8 plus 8, still not big enough. So I go on to 3. 3 gives me 27 plus 18. 9 times 2 is 18. Not quite big enough, so let's try 4. So this step does take a little bit of time. 4 times 4 times 4 is 64, plus 16 times 2 is 32. Take away 96. Yay, that's equal to 0, and so I get a remainder of 0, which means that 4 is one of my roots. And now that I have a root, I can continue with this. So I know that this divides by W minus 4, and what's left over I don't quite know, so I do synthetic division to figure that out. So 4 is, W minus 4 gives me a root of 4, and then the coefficients are 1, 2, there's no W's, and then take away 96, and hopefully I get this remainder 0. So add, multiply, add, multiply, add, multiply, add. So I get W squared plus 6W plus 24. Okay, so does this part factor? Well, are there two numbers that multiply to 24 that add up to 6? So it could only be 1 and 24, and 2 and 12, and 3 and 8, and 4 and 6. And notice basically I'm doing possible factors. I'm doing kind of the step I did for synthetic division. I'm just doing it this way. Well, those aren't going to give me 6, and nor are those, and nor are those, and nor are those. So it won't factor easily. It could still produce answers, but I'm going to need to use the quadratic formula. Let's check that. Well, before I actually do the whole quadratic formula, let's just check the discriminant. So b squared minus 4ac, because if it's negative, then inside the square root is a negative, and I'm not going to get any solutions. So b squared, that's 36, minus 4 times 1 times 24, which is 36, take away 96, which is negative. So guess what? Even trying the quadratic formula doesn't give me any extra solutions. So this lets me know that w equals 4 is the only real solution to this. And I can move on to the last step, and the last step is to answer the original question. And in this case, that was, what are the dimensions? So the width is 4, and the units are centimeters. The length is 3 times 4, which is 12 centimeters. And the height is 2 more than the width, which is 6 centimeters. And I've answered in a proper English sentence the question that was asked. So when you're doing these questions, yes, we'll be doing some factoring of some fairly large polynomials, but we need to make sure we do all 4 of these steps so that we're fully communicating our work, and we also need to make sure as we're going through it that we're thinking about the restrictions on our variables, and different questions are going to cause different restrictions to occur, so we need to have that in the back of our mind as we're going through and solving. I have also seen people who don't communicate their final answer properly, or they don't answer the question that was asked, so please make sure you just take an extra second to slow down at that last step and actually answer the original question in a full, proper English sentence. Okay, we'll see you in class.